What's new in Java 23 and why should you care about it? Find out from the best leaders and experts who are closely involved in creating these new Java features and the ones who will help you to use them. And in today's episode of JEP Explained, we will cover JEP 455, which is about adding primitive types in patterns, instanceof, and switch. So get ready to discover what you have been missing all these years. And to do that, we have with us today Brian Goetz, Java language architect with Oracle.
Hey there, thanks for having me.
We have Aggelos Biboudis, principal member, technical staff, Oracle.
Hello, thank you for the invitation. Pleasure to be here.
And Tagir Valeev, Java team technical lead, my colleague at JetBrains.
Hi, it's nice to see all of you.
And I'm your host, Mala Gupta, JetBrains. So, Brian, I want to start with you. First, an interesting observation. So, when we talk about a new feature, we realize what we are missing all these previous years, like inclusion of primitive types in switch and pattern matching. And now the question, was this inclusion a part of the bigger plan that was being rolled out in phases, or did it become important as pattern matching was being worked on, or part of some other project like Valhalla and value types?
Yeah, so I think the answer is yes to both of these, right? It's not like we started with a big master plan 10 years ago that's been secret in a locked room and we're like doing little bits of it at a time and rolling them out like, in a dramatic fashion. The reality is that the design emerges as we work on it, think about it, make observations, comparisons, connections, etc. So we've been doing this pattern matching saga for probably 5 years. And, we started out with the sort of most basic and obvious and useful, pieces. And then we slowly grew the scope of pattern matching and filled in a lot of missing bits as we went. And this particular JEP is an interesting one because you could think of it as adding a feature, but I prefer to think of it as removing a restriction. And, to your point, we realized what was missing. We live with these restrictions all the time. Like you can use primitives here, but not use primitives there. And we're so used to doing that we don't even notice. But, they are restrictions and they are cognitive load that we carry around with us as we think about writing Java programs. And so for this particular feature, my hope is that it actually makes the language simpler by removing ad hoc limitations and restrictions and applies one set of rules for, across the board for what you can use an instance of, et cetera. Of course, we may not achieve that goal exactly, but that's certainly part of the motivation is we want to make things simpler and more uniform.
That makes sense, removing restrictions. So, Atlas, I want to ask you, since you own this JEP, share with us the essence of the JEP. So, anyone and everyone who's watching this interview, what are the takeaways that you would like to have for them? How are we removing the restrictions, as Brian said?
Very, very good question. So, as Brian said, the key insight is about uniform data exploration, I would say. So users are going to use type patterns of all types, primitives and reference types, and across the board of kinds of patterns, either in a nested position or a top level position. So now when we want to explore our data and object graphs and etc., we have like nice constructs to like analyze and disaggregate our data. And essentially, what Brian said, I really highlight that this is about dropping limitations in pattern matching. So a limitation can be, for example, that in switches the selector type couldn't be long and double dropped,
Yes.
or that you can do a case person of int, and that could be pattern matched over only record classes of person of int. So we say that invariant, like int should have been int. We dropped that as well. So now you can use other types as well. And what is derived from all these limitations that are dropped is a single principle that casting is the basic building block and cast conversion, because we envision the language to be safer, and casting sometimes can result in class cast exception. It can lose silently information if you cast one data type, primitive data type, to another. So removing limitations, creating the cross product of all combinations, like eligible for switch and instance of, revealed that casting is the most important topic, and users will be safeguarded from casting. I think that's the essence. Yeah.
Yes, that makes sense. And as you said, when we remove all these restrictions, users or developers would be able to use the type. The primitive types in pattern matching, and that would be help them to replace the long if else statements with the more concise switch constructs, which I absolutely love. And I would come back to you regarding the conversion of the data part that you mentioned, let's say between byte and int. But before I do that, Tagir, I have a quick question for you. We know all these amazing features are coming with the language. So how does you, as the Java lead, ensure that developers are able to adopt it? Because I know we have some amazing inspections in IntelliJ IDEA. So how is your team helping developers to adopt these features? What good things are we seeing in IDEA?
Well, in general, yes, we try to recommend new features as soon as they appear in Java. And if like there is exist an old construct which can be converted to the new one, then we either add an like intention action which you should explicitly invoke, or even more aggressively we highlight something in the editor and say that in this case you can apply the conversion and use shiny new feature. This doesn't always work well because sometimes it's too aggressive. Like we aggressively promote new feature, and then people start complaining like, "Oh, I don't need, for example, method references everywhere, or using var type everywhere. I just don't want it." And after like one or two releases, we lower the like severity level of the inspection, or sometimes hide it altogether. But this does its job. A lot more people become aware. So I can show, for example, related to our feature, how it's implemented for conversion from if to switch. I can share a screen now. And for example, you can see this plain old Java 1 switch. We will not highlight it because it looks nice. Why highlighting it at all? But if you press Alt Enter, there is already an action which is a little bit aggressive because it really tries to convert this chain of ifs to a switch. And some people may complain that this construct is probably too verbose. Like we created one more variable I for thing we already had, which is x. But this will greatly improve learning. People will be aware that such kind of construction exists, and they may use it in other cases when it's more useful.
So Dagi, that's an interesting and a very good helpful inspection, because when I demo that in my talks, people are like, "Oh my God, I can use this feature even though I do not know the syntax of the newest Java feature, or even if they do not know anything about it, they can use it." And I think that's the most beautiful part of this inspection.
Yes, exactly. That was like my favorite thing is conversion loops to streams, which appeared after Java 8. So, and people were really excited. Like they don't even know to learn syntax of new streams. They just can convert automatically and learn what IntelliJ suggested to them. So I guess many people were happy.
So, Aggelos, I have the next question for you. So, in the JEP, you talk about deconstructing a record, say person, which has the components name, which is of type string, and double, which is a weight, to person, string name, and byte weight. So, my question is, why would you want to deconstruct to a different data type? Why would you want to deconstruct a record to a data type which has different to components, record components which have different data types?
Yeah, that's a very good question. I think it's a matter of bridging two worlds. This topic, for example, we can have a data representation world, and we need to map, I don't know, text files via JSON towards like a double, and we get this specification from somewhere, but in our own code, we need to offer further or like implement further validation of data and to enforce some invariance during creation of objects or deconstructing of objects. So by being able to restrict types and use this knowledge from our domain to the code in a type safe manner by by relying on the language to offer that to us, the user can write byte B, and then the pattern matching worked for our service,
Mhm.
like in that way.
So, Brian, I have a similar question for you because so there was also a mention about in the JEP that there are no different data conversion rules being added when primitives are being used in pattern matching. But there was a code snippet in which you have a switch construct. Let me quickly share my screen so that it's much more visible. Yes. So this. Oh, yes. So this is what we have. I could use a switch construct to have the implicit conversation, but the commented code at the bottom, that doesn't work. So how does that work? And your comments.
At the risk of putting on my architecture astronaut hat, I want to make a couple observations about what pattern matching really means, right? And so what there's a visual similarity between declaring a local variable and a type pattern. String s equals for a local variable, instance of string s for a type pattern. There's a visual similarity between a record constructor and a record pattern. And this isn't accidental. And what we want people to be thinking when they see a pattern match, like if something instance of foo of, some enclosing pattern, is that they're asking a question of, could this instance have come about by invoking the corresponding constructor here? And if so, tell me what things I would have to fill into the holes in order to make that true. And so pattern matching is, in some sense, a controlled reversal of abstraction. If I have a variable string s and I assign it to object O, well, I've abstracted away the type from string to object. And we've always had the instance of operator in the language as a way of recovering from that lossy abstraction. I threw away the type information when I widened from string to object, but then I can say, would I be allowed to go back from object to string with instance of? And pattern matching is a generalization of that. You're saying, could this thing that has a general type could have come from something that has this specific type? And so going back to your question about the switch, uh, the reason that you can say case person, string name, byte weight is you're saying, could this have come from passing a byte to the person constructor? If so, recover that byte value for me and bind it to the local variable weight for me. But trying to do that directly, the language won't let you do that because that's a potentially lossy conversion. And so patterns are intrinsically conditional, And so, therefore, you can do more things with them because there's always the possibility that the pattern doesn't match and it won't try to use something in an inappropriate way. And so, coming back to the point that Aggelos made about casting conversion, the best way to understand what a type pattern means or what instance of means is if I say instance of type or instance of type pattern, I'm saying, could I safely cast this thing on the left to the type on the right? Where safely means it won't throw an exception, it won't throw away information like truncating the high order bits from a long. Uh, it's a way of saying, could I have come from this, and if so, let's get back there, to what I started with.
That makes sense. So, Tagir, I want to ask a question to you now. When you implement the same in IntelliJ IDEA, does that pose a challenge to you on implementing this part?
Well, speaking of this particular feature, it was not something like uh, a whole new part of functionality somewhere. It was rather
Mhm.
like improving something this, improving something that, and so on. Because we already had pattern matching, we already had switches, we already had instance of, and it's just changes in existing feature. So uh, this JEP didn't add any new inspections, for example. But existing inspections have to be updated. And as for any feature, we had to update our Java parser, we had to update our syntax highlighter, our error highlighter, because even very small features add new error messages. And for error messages, you definitely need quick fixes. Then you need to update existing inspections, like I shown if to switch, also switch to if. There are also others like a new style switch to old style column switch and so on. They should understand they should not break when they see new kind of construct. We also need to update refactorings. We also need to update code completion. So for example, if you at position after case, now you should be able to complete primitive types. Before it was like useless, and we should support it. So it was like many little things, and the most challenging thing is probably to forget something, because it's possible that, well, we have like 1,000 of Java inspections. It's possible that there is still exists an inspection which does something with switches or something with instance offs, and it will go crazy when it will encounter new primitive type inside instance of a switch, and it will do something wrong or will fail with an error. So it's possible. We try to test thoroughly, but who knows?
So everyone's watching. If they're trying out this feature in IDEA, and if they find anything, you know who to ping. Tagir is the
Yes.
person.
By the way, if I can a little bit continue, uh, I really like this feature from the point of IntelliJ IDEA developer. Like probably it's not so useful for regular Java users, but in IntelliJ IDEA we have quite uh, sophisticated static analyzer, and a part of it is uh, number range analysis, which is quite also very non-trivial part. So basically, if we know something about numbers, we can derive many facts and eventually derive something like condition is always true or something like this. And uh, this feature is like really communicates with our static analyzer. So it was pretty easy to add new functionality because we already had a model of like integer ranges. So I can show, for example, here, uh, if you write something as simple as x instance of byte, now you have highlighting that this condition is always false, because if x instance of byte, it's already cannot be 1000. And we had everything inside to support this, so it was not very hard to add this functionality. Sometimes it works even for doubles. So for example, if double instance of int, we already highlight that it cannot be none anymore, or it cannot be negative infinity anymore. Here model is a little bit like limited, so we don't know about floating point part. So this condition is technically also always false, but our model doesn't know about it. Still, it was nice that new feature automatically improves our static analysis in like pretty easy way.
And that's not surprising. There's an old joke that says if you let a compiler writer design a language, you'll get a language with pattern matching, because the internals of compilers are all about tree transformations and predicates on trees and all of that. And so since IntelliJ is a big compiler on the inside, I'm not surprised to find that you use this feature a lot.
So, so the next question, Aggelos, I want to ask you is because you have been working on this JEP for quite a long time, and whenever we are working on any task, so we kind of knee deep into this, and a lot of times we assume a lot of things which the other folks might not be aware about. So, I wanted to talk about the challenges that you might have faced while working on the features, and what is it that you would like to highlight and know others to know about this feature?
Yeah, very, very good question. So, like the way that the language feature grows is that there is a vision that is implemented. And particularly for Java, it needs to be done with respect of all the pre-existing code and vision for like future code. So we are talking about many, many decades, like in both sides of this range. And in order to communicate ideas, by the way, the key word here is dialogue. This is a dialogue between implementers, between someone who thinks the specification, between the community. The community creates sends back insights, uses, reports bugs. Like it's a continuous dialogue, and there's communication, specification, language, prototyping, like performance work that happens at the same time, and keeping those things in sync is very interesting. It can be challenging, but it's very interesting, and it's an ongoing process. This is my take. Brian, what do you think?
Designing a feature is often a lesson in humility. You start out thinking, "Oh, this is going to be easy. We're just going to do this, and we're going to be done." And then the waves of reality crash over you. These may be technical debt in the specification, or interactions with other features that you haven't thought about, like serialization is a common interactor with language features. um, and so you start out thinking something's going to be simple, and then things grow. And this JEP is a good example of that. It started out just being about primitive type patterns and primitives and instance of, but it very quickly extended to cover limitations on switch, and treatment of primitives in other contexts as well. Because what we discovered was, when you fix one thing, it just moves the problem from here to there. You used to not be able to write this code. Now you can write this code, but then you try to do a simple refactoring, and the thing that you'd like to refactor it to also isn't valid. And so you have to fix that. Otherwise, you've just moved the problem around. So it's often a humbling experience when you start out, even with something that feels like a small feature. It ends up never being a small feature.
I can
That,
add something here, particularly for
sure.
this just personal experience, testimonial.
Mhm.
So, like the key idea is that instance of is really the precondition for safe casting. And then we want to drop all the limitations that we discussed before, and we go to the chapter of the specification that talks about casting conversions, and then there is a bunch of casting conversions, like 10 here for primitives types and another like number for references. And then you need to go one by one and ensure that the vision of safety works. And then floats come in. And then you realize about cars and shorts that are narrowing conversions, like both from car to a short and from a short to a car. And then you realize things, and you want from one side to drop limitations, and then the specification grows because you want to ensure the things that the language should do. So this is the realization.
Yeah, and just to add, there's something I have a special fondness for this Jeff, because it is unlike, it's something that happens somewhat rarely, which was we spent a lot of time talking about how should this work, what should this mean, what should it mean to say instance of int, etc. And we went back and forth with examples, and some people were uncomfortable that instance of starts to use the value and not just the type of the thing on the left side. And as we read chapter 5 of the Java language specification over and over and over again in this process, which I kind of encourage people to read this chapter, because on the one hand, it seems very big and complicated and covers a lot of special cases, but after you read it, you'll find that nothing in it is surprising. It just took that many words to say what was obvious to people about what they understand about how Java works. This chap was really an example of, if you listen very closely to the specification, it will tell you its secrets. And so after the process of reading over and over and over again, we realize that the answer to what instance of should mean in the context of primitives was latent in the specification for 30 years. And we didn't invent it, we just sort of let it out. And that's a very nice feeling. It doesn't always work that way, but when it does, it's very nice.
That makes a lot of sense, because Brian, what you said, it's always been there. It was there. You did not invent it. Just kind of knowing that it existed. And I hear that comment a lot from. So I did my Java certification way back in 2002, and I kind of read a lot of things which a lot of people do not do now. And now when I talk with developers and they tell me, "Oh, this is how it works," I said it always worked that way ever since Java 1.0. So that makes a lot of sense. And also, I absolutely love the fact how the language features that you add, they work. They are backward compatible, because when you talk about, let's say, I'm talking, taking tangent, talking about the other JEP, which talks about modifying the order in, if I could call super before super and execute some code. So that would work exactly according to the Java specification, because you're not modifying the execution of the code of the super and the base class. So that works really well. So I absolutely love this part about backward compatibility and kind of working and building up on things which already exist and just working your way up. So, Brian, I have the next question for you. Um, uh, if you think you've already answered this question, we could skip that one. So, you've talked about data-oriented programming a lot in the past. How do you think this JEP adds to that topic?
Yeah, so the entire pattern matching saga sort of fits into that nicely, right? So
Mhm.
I think the programs that we write today are somewhat different from the programs that we wrote 15 years ago, and this is in part because changes in deployment technology, moving to the cloud. We used to have these enterprise monoliths. Now we try to focus on building smaller services that do fewer things. And so what that means is that the code that we write is closer to the boundary of the program than it used to be. It used to be you had this big monolithic enterprise program. It was Java objects end to end. If it went from one machine to another, it got serialized and deserialized. So you had the illusion that the object, was just always there. And now we're writing more programs that respond to requests coming in by JSON or YAML or XML or whatever your favorite encoding is. And that means that you're dealing with type systems from outside of Java all the time. The notion of number from JSON is not the same as Java's int float long double, numeric tower. And that means you're constantly going to have to be converting from whatever was valid in the external representation. I had to figure out what the right internal representation is, make sure it's in the right range, and reject it if it's not. And pattern matching is a perfect, answer for all of that. Because it allows you to mediate this conversion in a way that acknowledges it might not convert. The data might be bad. I might not be able to represent this number in a 32-bit integer because it's too big. Even if it syntactically matches the regular expression that says, it's a sequence of digits, maybe with a sign in the front, it still might be too big to fit into an int. And so pattern matching lets us ask questions about data and say, does the data have the right shape? And convert it to the shape that we want so that we can use it and get on with our day. And we're not writing programs as much that deal with these long-lived objects that model complex processes with mutable state and all these complicated internal invariants. We're not writing that code anymore. We're not writing that code as much. And so as the programs we write change, the techniques that we need for writing those programs change.
Right. And as you mentioned in one of the previous answers, you are lifting the restrictions. So now the developers don't have to kind of think about what data they're working with, because with primitives in pattern matching, they can work with any data. So that's amazing.
Exactly. Yeah.
So Tagir, I have the last question for you before we move on to our fun sections. So the question is, what would you want the developers to know? So if you can think about one feature they could use in IntelliJ IDEA so that they could adopt this feature with much ease.
Uh, if you are speaking about this particular JEP, I would
Yes.
suggest developers to pay attention to if to switch converter, because there are definitely if statement chains in a big code base, which could be converted to nicely looking pattern matching switches, and now with primitive types as well. So you may even try to apply this en masse and then just go through the diff in your code, like go through the changes against your previous committed version and see if you like it more or if you like it less. If you like it more, sometimes you can accept this change. And in any case, we will learn how it works. So I guess this would be the easiest way to understand the feature.
That makes sense. And I love that feature. I love that inspection. So, Brian, in Aggelos, before we move to the fun sections, if there's anything that you want to add or highlight, please do about this step.
So one of the things that the comments that we get, when we publish these JEPs, we get some interesting comments from users, and one of the bits of feedback that we saw very frequently on this JEP was, what's the point? I don't ever write code like that, right? And it kind of highlights the way that I think most developers are kind of like prisoners in their little world, right? They have the view of, this is the kind of code I write every day, and that's the most important kind of code to
Mhm.
write, and I care about features that help me write that code. We look at it very differently. It's not that we don't care about your code or Tagir's code. We care about everybody's code, right? So when we look at evolving the language, we try to pick features not necessarily that are going to make any one developer's lives better, but to make all of the Java code in all of the world better on aggregate. And that's often often results in decisions that people don't always think are obvious, either because it's not focusing on the problem that they wish we would focus on, which is a very common thing that we get from people, or that it looks like it's focusing on something cornery and esoteric, But in reality, a JEP like this, like I said, is about eliminating restrictions, not just, to be more uniform, but so that people don't have to carry around so many rules in their head about, I can do this on Mondays, but not on Wednesdays, right? That kind of accidental
Mhm.
complexity is like a weight that we all carry around. And a lot of new features that we add end up adding new complexity, and that's a shame, but it's sometimes the cost of doing business. But it's really nice when we
Mhm.
can remove complexity by eliminating gratuitous restrictions. And this was a really nice example of that.
I think it's a very big responsibility, and you're doing it very well because it makes a lot of effort and consideration to create a feature which could be used by a lot of developers. And as you mentioned in one of your earlier sessions, when we talk about the preview language feature, it has to work with all the other feature. And unlike an API, it cannot be deprecated. So a lot of consideration and responsibility goes in when you're talking about a new language feature. So many congratulations to you, and hats off to you,
Thank you.
to the team. Aggelos, do you want to add something or?
I couldn't have said it better, but yeah, it's the main idea is regularizing things indeed, and for this in particular, instance of is a first-class citizen for users, and it's also a building block for pattern matching itself. And the main idea is that it's really the precondition for safe casting. So asking if some form of data, I don't want to say object, so let's say some form of data is an instance of a type, actually means can I cast this of that type to the other type? This is just the essence for that. So
Thank you so much. It was a very interesting conversation. And with that, we'll move to the fun sections. So, Brian, we'll start with you. The section name is Myth or Fact. So, I would have a sentence for you, and then you have to clarify or state whether that's a myth or a fact. And if it's a myth, you have to give us the correct statement. So, sounds good?
Okay, we'll give it a try.
Okay, so the first statement is Brian is known in his circle for having a great sense of humor.
No, that's a definite myth. I'm a very serious guy.
So I think Aglos has something to say about that.
best sense of humor. I sign under this statement.
Okay, so the next statement for Brian is folks never complain about the new language features being copied from other programming languages.
Can you really copy a feature from another programming language? I mean, it is like one of those tree falls in the forest questions, right? It's like if you copy a feature from one language to another, is it really the same feature? It's kind of like, do all objects have identity? I'm not sure, but
That's a good way to say that.
but yes,
But people
people
do
people
complain.
complain about this all the time. That's true.
Okay, so the last statement for Brian is Brian has a cat.
It's a trick question. Brian has two cats.
Well, well, it means that at least you have one cat.
Yes, Tagir nailed that. Good, good. So now, so we'll move to Agleos now. So Agleos, the first statement is your LinkedIn recommendation include praises about your sense of humor.
Hmm. I think that's true. It gives some clearance to my head, like when I try to assess a situation in a light manner. Maybe it
Mhm.
hides the drama behind it. I don't know, but it's like, or maybe it's a coping mechanism. I don't know, but it works.
And I talked with you. I think this is the first time that we're talking, but I can also say that you also have a great sense of sarcasm, and good sense of humor and good sarcasm. They are deadly mix. So it's difficult.
Right.
So the second statement is folks usually pronounce your name correctly.
This is a lifelong journey. I don't think I will ever address that because all my life I wrote my name in English in a certain way. Then the passport came later on according to a ISO standard, and then the transliteration of name was very uh,
Mm.
specific. Then people got confused. I think it's a myth.
Yeah, I don't even know it for real. But
Right.
And the last one is you're very passionate about your work and this job. I think I should be answering that question, or I should be answering that. It's a fact because Axios is on his vacation right now, and he's been so kind and so committed to the work and the job that he's working on that he's agreed on being a part of this interview. Thank you so much. We really appreciate that.
Thank you as well for inviting me. As I told you, I think this is part of the vacation because it's like a
Wow.
very interesting discussion between similar minded people. And I think this is pure fun. Thanks a lot.
Thank you so much. So, Tagir, now it's your turn. So, the first statement is Tagir likes to talk and it's difficult to make him stop talking.
Mm, I think it's mostly true. Like sometimes I'm not very talkative, but if I go to the flow, then it could be really hard to stop because if I like the topic I'm talking about, I can talk for probably for hours. At least uh, my wife often says like, "Stop, it's enough."
So, the answer depends on the context because Brian started nodding as soon as I said yes. He's very talkative, doesn't stop. Right. So, the next statement is Tagir hates running. Myth or a
Uh,
fact?
That's actually a myth. That's opposite. I love running. I run pretty much, and I run outdoors. For me, it's not only running, but more about exploring the world. I like running to unusual places, places where Google Map cannot cope well, and sometimes I need to jump over the fence or something like this because
Oh my God.
otherwise I cannot get out. It's really fun. It's kind of having a little bit of adventure in my life.
Wow, I think your neighbors do have a lot of interesting time with you around. So the last one for Tagir is usually working on new Java features, late nights and or weekends. I would answer that for Tagir because yes, even if I'm pinging on weekends, late nights, he answers them right away. So yes, he works on those things almost around the clock, Tagir, if I'm not wrong.
Uh, it's true that I'm. Uh, oh, hello. Yeah, it's true that I can answer something or discuss something with colleagues outside of working hours, but usually I don't do my actual work outside of working hours. Instead, I'm
Mm,
doing something, some pet projects, but they
mm,
are usually also connected to Java. Like uh, my previous big pet project was writing Java book, so I
wow.
was like
Wow.
working on Java during day and writing the book during the night, but
Mm.
it's still connected to Java. So I guess you're right.
Yes, so that's a fact, right? So
Yes.
now moving on to our next section, which is about tongue twisters. So Brian will start with you. I will show the first tongue twister, and if you are able to say that right, then we'll move on. We'll show the other tongue twister to the other participants. But if you are not able to say that right, then we'll show the same one to the others as well. So Brian, this is for you.
Java tests with pattern quests, switching types, and matching tests.
Oh my God, you are quite good with that. So probably you can try saying that thrice in quick succession. How's that? Let's make it difficult for you. Yeah.
You want me to say it twice?
No, you'll have to say that twice, not thrice. You have to say that twice in quick succession so that you falter.
All
Sorry.
right. Java Jest with pattern quest, switching types and matching tests. Java Jest with pattern quest, switching types and matching tests.
Oh my God, you're too good.
You
You're
are
too good.
incredible.
What do I win? Did I win something?
Oh, absolutely. Absolutely. We'll ship that to you. So this is for Aggelos. So we'll change that.
In Java's high pattern stripe, switching swiftly types alive.
Oh my God. You all are too good. So Tagir will have both for you. First this
Oh,
and then the other one.
how have you even created them? Oh, I see. It's
Uh,
probably AI assistant. Yes?
so that's a combination. So I tried multiple things. So I picked up the keywords from the JEP itself, and then I used the AI assistant to give me a tongue twister.
I see. Finally, a good application for AI assistant. Just
Yes.
joking. Okay, my English is not so good, but I'll try.
Mhm.
Java Jest with pattern quest, switching types, and matching tests.
And now this one.
In Java's Jive, once more.
Yes.
In Java's
Yes.
Jive, patterns thrive, switching swiftly, types alive.
Oh, not bad. But Brian gets full points. Aglas gets 2. 1 point cut for Tagir. So,
That's fair.
okay. So coming to the last section, which is answer in emojis. So so this is for all of you. I would say, so you can do that together. So I would say one line, and you have to answer in emojis, not by typing it out, but you have to act it out. So you have to use your hands and face to show the emoji that you would use for that statement. So the first one is Java 23 is about to be released. This is fun. This
The
is fun.
fireworks one.
The second one is always great to have a pet at your work desk.
I have a very high resolution emoji for this one.
Oh my God. This is amazing. And the last one is running a marathon is wow. That was so much fun. Thank you so much, everyone. It was an absolute pleasure to talk with all of you. We learned a lot about the JEP and otherwise as well. So, thank you so much for your time.
Yeah.
Once again, lovely to talk with you all.
Thanks a
Thank
lot.
you. Thanks a
Cheers.
lot.
Thanks so
Thank
much.
you.